Hello and welcome. My name is Joshua Kennedy. Today I'm going to show you my gravity simulator. By the end of this video, you should have an understanding of Newton's second law of physics and how to use it in Unity game engine for yourself. Let's take a look at the formula Sir Isaac Newton wrote back in 1687, 337 years ago. The force of one gravitational body to another is equal to the big G, a constant, multiplied by the mass of the first object times the mass of the second object divided by the distance between them squared. So let's go ahead and take a look in Unity Game Engine. What we have here is we have two different game objects. We have Planet 1, Planet 2. And as Planet 1 is heading towards Planet 2, we can see that they're pulled towards each other. Now the only two things that I need you to worry about as far as the components that are on these game objects is we have a transform, as always. We have a script that I wrote and will be showing you shortly called Attractor. That's our main bread and butter. And then we have rigid body. Rigid body is the component within Unity game engine attached to that object that's going to be handling all the physics for us. Now the beauty of this is that any amount of game objects that we have in this scene that are going to have the Attractor script added as a component to that game object are going to behave just as we would suspect with celestial bodies in real life. Let's have a look at the Attractor class. This script is going to be able to be attached to any game object in Unity so that we can simulate the gravitational attraction between all other objects with the Attractor class. Let's have a look at the variables in this script. We're going to have constant float g, which is going to be equal to 667.4. Now that's going to be the same as the gravitational constant in Newton's law of universal gravitation. However, we've changed the magnitude to work for Unity game engine. Next, we're going to have a list with elements attractor, and so we're going to call that list attractors. And so this is going to be a list that's going to contain all the game objects in the scene that have an attractor component attached to them. And then finally, we're going to have the rigid body, which is just going to be the reference to the physics of this particular instance of that game object. Next, let's have a look at the methods in this script. We have fixed update, which is called 50 times per second. And then we have, for each element attractor in the list of attractors, we're going to say, if that attractor is not this game object, then we're going to attract that attractor. And then we're going to go into that method attractor. But before I do that, let me really illustrate the point. That if this first planet is being called, has its script attractor, it's going to say, give me these other three planets, and I want to attract them towards this one. So we're going to create forces towards that first planet with this script. And it's going to say, get the rigid body of that other object, so the planets 2, 3, and 4. And then we're going to determine the direction by taking the vector of the position where it is subtracted by our position. And then we're going to find the distance by taking that direction dot magnitude. And then just to prevent any errors, we're going to say if the distance between the two objects is 0, go ahead and return and get out of this method so we don't need to do any of the calculations. Then we're going to calculate the force. The force is going to be equal to that gravitational constant multiplied by the mass of the first object times the mass of the second object divided by the distance between them squared. And that's exactly what we have. We have big G, the variable we called as a constant in the beginning, multiplied by the rigid body dot mass of the first object times the rigid body dot mass of the second object divided by the distance between them squared. And that's going to give us the force. Now, our force vector is going to be just a magnitude and a direction, as all forces are. And we're going to say the direction is going to be that direction normalized multiplied by the force magnitude. Now, we'll need to apply that force to that game object in the negative direction. Because again, we're not wanting the force to go this way. We want it to go this way towards the other one. Lastly, we have two methods here that are going to say enable and disable. When it's enabled, if the attractors are not equal to null, then we're going to create a new list, and then we're going to add this attractor. So upon this game object being enabled when the scene is started, we're going to add it to the list. On disabled, we're going to remove it from the list. And that's it for the methods. So now that you've seen how these planets are being pulled towards each other using the attractor script, I would like to take a moment to demonstrate how crazy this can get. Right, so I can just keep creating more of these and more of these, and upon enable, when these things are created, it's going to be able to figure it out. It's going to know all the different forces that are being pulled on these. And as you see, it gets pretty crazy. But I just love that in abstract space, we can still see all these different forces working perfectly. Oh, so we have some that are reaching their escape velocity. And then we have others that are pulling in. In the end, this is why I love Unity game engine so much. I'm able to not just simulate physics and mathematics that I used to only once be able to do on paper. I'm really able to create an entire little universe. I'm able to see how things work in real time. My own little sandbox of math and physics. It truly is one of the greatest honors to have this much power and this much capability in my hands. All the way down to the equations that created the universe that we live in today. If you'd like to download this project, please visit the GitHub link in the description below. Thanks for watching. Until next time.